Have you ever thought about the invisible force that runs pretty much everything you do? It's the reason you can walk across a room, the reason a car can stop at a red light, and the reason your life isn't just one long, endless slide. We're talking about friction. And you'll see it's got two very, very different sides.
Seriously, think about it for a second. What lets you just walk, or run, or slam on your bike brakes when you need to? What's that secret ingredient that's giving you all that control over your movement?
Yep, you guessed it, it's friction. It's what we call a contact force, which really just means it happens whenever two things touch. And its entire job, its only purpose in life, is to push back against motion. You can think of it as the universe's own built-in brake pedal.
Okay, so a lot of us think of friction as, a drag, something that slows things down. But let's flip that script for a second, because in so many ways, friction is the unsung hero of our everyday lives.
I'm not kidding. Without friction, the world would literally be one giant, uncontrollable slip and slide. Every single step you take depends on the friction between your shoes and the ground. It's what lets a car's tires grip the road and go, and it's the entire reason brakes actually work. It's the grip that lets us get a handle on the world.
And that really sums it up, doesn't it? Friction isn't just about hitting the brakes. It's the fundamental force of control. Period. Without it, everything would just be a chaotic mess, with stuff sliding around forever.
But, and it's a big but, that's not the whole story. For every heroic thing it does, friction also has a dark side. Sometimes it can be a real villain, working against us and creating all sorts of problems that we have to solve. And this is the core of the problem, right? The exact same force that gives us grip is also the one that grinds things down, wastes energy, and just generally makes it harder to move things efficiently. Why? Because if you look at any surface under a microscope, it's not smooth at all. It's all these tiny mountains and valleys that snag on each other.
Just think about the chain on your bike. That grinding day after day literally wears the metal down. Or, rub your hands together real fast. Feel that warmth? That's friction turning your effort into heat. Now imagine that happening inside an engine. That heat is just wasted energy.
So that's the big question, right? We can't live without it, but sometimes we can't live with it. This is where we humans get clever. We figured out how to manage friction when it starts acting like the bad guy. So how do we fight back?
The answer is lubrication. It's a pretty brilliant solution, actually. You just put something slippery, like oil or grease, between two moving surfaces, like that bike chain we talked about. It creates this super thin film that lets the parts glide past each other instead of grinding each other to dust.
Okay, so we've got this two-sided force. It can be a hero, it can be a villain. But how much friction are we actually talking about? Is a road 10 times grippier than ice or 100? To figure that out, we gotta measure it.
Well, if you want to test it like a scientist, you've got to be fair about it. The golden rule is only change one thing at a time. For us, that's the surface we're testing. Then you measure the thing you're curious about. In this case, how much force it takes to pull something. Everything else, like the object's weight and how fast you pull it, has to stay exactly the same. So the actual experiment is pretty straightforward. You grab a little force meter, hook it up to a weight, and then just pull it at a steady speed across different surfaces. You do it a few times to get a good average, and by measuring how hard you have to pull, you get a perfect comparison of which surface is grippier.
And boom, look at the results. It took way more force to pull the object across surface B than it did for surface C, more than 3 times as much. What does that tell us? It's simple, really. The surface you're on makes a huge difference in how much friction you have to fight.
All right, so we've been talking about solid things rubbing together. But get this, friction isn't just for solid ground. You're fighting it anytime you move through anything, even something as seemingly empty as the air all around us.
When you move through a fluid, and yeah, air counts as a fluid, the friction you feel is called drag, or air resistance, and it has one simple rule. The faster you go, the harder it pushes back. You know this. It's that feeling when you stick your hand out of a car window on the highway and the wind tries to push it back.
So that creates this massive problem for anything that needs to go fast, like a race car or a jet. The faster you try to go, the harder this invisible wall of air pushes against you. So, how do engineers design something to slice right through that wall instead of just crashing into it?
One word: streamlining. It's an absolutely beautiful concept. Instead of trying to brute force your way through the air, you just reshape your object to convince the air to flow smoothly around it. It's the difference between hitting a wall and being a knife. And once you know what to look for, you see it everywhere.
Those sleek, curvy Formula One cars? Streamlined. A professional cyclist's helmet. Yep, that weird teardrop shape is all about streamlining. Bullet trains, airplanes, it's all about cheating the air to go faster.
So we come back to our original question. Is friction the hero or the villain? And the answer, of course, is it's both. It's this amazing paradox. We absolutely need it for control, but we constantly have to fight it to achieve speed. The real magic is in the engineering that lets us have it both ways. So next time you tie your shoes or watch a jet fly overhead, just take a second to appreciate that you're watching this incredible dance with one of the most fundamental forces in our universe.